Okay, so this video is about 1x2 array using HFSS. So let's start. First we'll draw the ground plane. So we'll just select the rectangle here and then just place the random rectangle. Then we'll name this as ground, change the color. Okay, display line should be off. Okay, now create rectangle. The dimensions for the ground are, the position is -60, -50, 0. X size is 120, Y size is 70. Then click OK. Fit all. This is your ground plane. Now let's go for the substrate. You can draw the box on top of the ground itself, so it will be easier. Yeah, so rename this as substrate. Then change the material from vacuum to FR4. So you search FR4 epoxy. Okay, then let the color be as it is. Okay, then create box. These dimensions will be the same as your ground, of course, just the height will change to 1.6. so this will become 1.6, and you click OK and your substrate is ready. Now let's go to the patch. So let's create the first patch. So just place it anywhere and you name this as patch 1. Change the color to orange to represent copper, and then press OK. It's gone. You cannot see it now because it's gone below. So when you go to create rectangle and add the height as 1.6, it will come back. So the position here is -50.25, -15, 1.6, and X size is 38, Y size is 29.2. So X size and Y size is calculated from the formula, and position is all trial and error, so keep that in mind. So yep, your patch is ready. Then next we'll finish one antenna and then go to the other. So we'll make the feed of this antenna. So just draw an approximate rectangle from here. This is your feed 1. Change the color to orange. Okay, then create rectangle. The position here is -32.75, -28, and 1.6. Then X size, oh be careful, there's no bracket here, my bad. X size is 3, Y size is 23. That is done. Click OK, and there's your feed 1. Let me zoom in if you want to see it more clearly. Then going back to the cut, so just approximately near the feed and the patch joining, just draw one rectangle and name it as cut 1. Name it as cut 1, and then change the color to orange just because I like it. Then the position for the cut 1 is -35, -5, and 1.6. X size is 8, Y size is -10. Click on OK and you'll see it here. Now first thing we'll do is patch and cut 1, and we will subtract. OK. Now patch 1, feed 1, unite, and our first patch is ready. Now let's go to the next patch. So pan, zoom out a bit, then create another rectangle somewhere over here because there's a separation of around 62.65.5. So yeah, I mean the rectangle can be of any shape because you can change the dimensions later. So name this as patch 2. Go to change the color, then create rectangle. Patch 2. The position is 12.25, -15, and 1.6. The dimensions will remain the same, 38 and 29.2. Okay, there you have your second patch. Let's rename this as patch 2. Okay, I don't know why it isn't changing the name. Apply. Okay, I don't know, probably some glitch, but yeah, we have patch 2 here. Let's make feed 2 then. Feed 2 from here, just draw one line approximately, change the name, feed 2, change the color, okay, okay, feed 2 is here. The position for feed 2 is 29.75 minus 28 and 1.6. Y size is 3, Z size is 23. Okay, so we have our feed also. Then last but not the least, for this patch we have our cut. So just draw an approximate rectangle, and this will be cut 2, and just change the color for funsies. Okay, cut 2, and now position for cut 2 is okay, so I don't have the exact position for cut 2. Let's just take the x size and y size as 8 and minus 10, and let's just see what happens. Let's change this to 1.6. If y size is minus 10, then this might be minus 5. And okay, so we can see it's not centered, so let's just try and center it. Let's take something maybe like 27. You can apply and you can see the changes happening in real time. So okay, 27 works, it's somewhere in the middle, so we'll just take that. Okay, now we do patch 2, cut 2, subtract. Okay, then we do so the position for cut 2 was minus 6, not minus 5, so minus 6. We do okay, and yeah, I think it's better now. That's size. Okay, now we do patch 2 and feed 2 unite. So we have both our patches ready here, and now we have to join these two patches. So the distance of separation between these two patches is calculated using the formula. So lambda naught is c by f naught, and here f naught is 2.4 gigahertz, so we get lambda naught. The distance between the two antennas will be d equal to lambda naught by 2. So when you do the calculations, you'll get the separation as 65.5. So let's just take a rectangle from here. Just draw an approximate rectangle joining these two, and let's name it as separation, or you can name it whatever you want, junction, or whatever you want to call it. I'll change the color to orange because that's what I like it. And yep, create rectangle. So the position is minus 32.75 minus 29.5 and 1.6. X size is 65.5 and y size is 3. So let's just do okay, and yeah, we have our separation. So let's select patch 1, patch 2 and separation and unite them. So yeah, we have our two patches joined together. Now we have to create our main feed, and then we are done. So for the main feed, let's just take another rectangle, place it somewhere in the middle approximately, and draw a rectangle. Yeah, just an approximate rectangle is fine, and then just name it main feed. Let's change the color to orange. Okay, and the position and dimensions for the main feed are minus 1.5, minus 50, 1.6, and x size is 3 and y size is 22. Let's do okay, and we have our main feed here. The name didn't come, so let's just name it again, main feed. Apply. Okay, now let's join the patch 1 and our main feed. So add, and yeah, we have our final design almost. Only thing left is port. So the for port, go here where my cursor is, change the plane to XZ plane, then choose the rectangle. Let me zoom into that place. So where the main feed is, you have to just draw. So I'll take out pan and I'll come back to draw mode. So, and I draw a rectangle. It might not come exact because of the grid space there. So just click a random thing and then select, name it as port, change the color to orange if you want. Okay, create rectangle. So we need the length of the port to be same as the main feed. So for the main feed, the X size was 3. So this will also be 3. And we click OK and we are done. Now what's left is to assign the boundaries and do the rest of the stuff. So we'll open this up for now. So the ground and the patch are all E plane. So I mean perfect E. So we go here, assign boundary, perfect E. Okay. Then the port will be assign excitation, port, model lumped port. Next, new line, and then you zoom in and until you find a triangle. This is a bit of a hard part. Escape. Okay, I don't know if you can see in the video, but you'll get a triangle shape over there. That's where you click and then you go up again. So I'll go pan, go up, and I will find the triangle again. So triangle. It's a bit of a hard part in this one. I don't know why, but find the triangle. Yep, here. I think you can see it a bit better now, and it's done. So next, I think you have to click on normalize, so you'll get this, and then you do finish. To confirm if everything is there, you can check on this side here, boundaries. So you have perfect E1. So fit all, this is your perfect E1, and then excitations, here's your port which is excited. You can see that as well. Now we have to create the rad box for the outside. So for the rad box, what you do is you fit all, orient, change the plane to XY because we were in XY, and now we just create a box. Just take any random dimension, and because you can obviously change it later, and do rad box, and then we have to make it transparent. So from transparency is 1. Okay, then we create the box. So the size of the rad box is -90, -80, -30. X size is 180, Y size is 130, Z size is 70, and we do OK. Fit all, and we have our rad box, and this is our completed design. One thing in the rad box which I missed is you have to change vacuum to air. So you do air, OK, and you have to also assign radiation to rad box. So assign boundary and radiation. OK, so you see perfect E1 and rad 1 here. So yeah, the entire design is ready. So next you have to do the analysis part. So add solution setup, advanced, this becomes 2.4, this becomes 20, this remains the same. Then you do OK, then you do fast linear step 1 to 3 gigahertz with a step size of 0.05. You can take the step size as much as you want. So I want as minimum points as possible for faster analysis, so I just took 0.045 and I have 41 points. Once that is done, then if you want, you can create the infinite sphere. So you can initially keep it as 0, 360, 10, 0, 180, 10, and okay. So yeah, everything is done. We can go do a validation check just in case, and then analyze all. You have to save your file, array 2.4. I'll just save it as that. Save, and now it should just analyze. Yep, normal completion of simulation on server is done. So now we can check our results. So results: create model solution data report, rectangular plot, S parameter, new report, and our frequency is 2.4 gigahertz with the S11 dip of minus 10.8894. So the S11 dip should be less than minus 10, which is the case with our antenna, luckily very close to minus 10. So yep, that is done. Now let's check the VSWR. So again, model solution report, VSWR, new report, and at 2.4 gigahertz, that's somewhere here. Yeah, it's 1.7. It's a bit high, but as long as it's less than as long as it's less than 2, we are good. So that is done. We can also check the far field report 3D polar plot, and we can plot our E field, and this is how the radiation pattern looks like. And we can also plot the radiation pattern in E plane. That will be the 2D plot. For that, we'll have to change the infinite sphere, so that's why it's looking like this, a bit weird. So the main things are the VSWR plot, S parameter plot, and the radiation plot. The max radiation is 13.93. So yeah, that was it for the video. This is the final design. I hope it helped.